I think for some of you, like I hope you enjoyed the last talk. It's really, I think it's really impressive knowledge coming from someone work on the fields, actually encounter those challenges day to day. And I work in a more useless profession. I'm a game designer, so I really don't solve real world problems. We create problems. So we are going to talk about using ADK, use a game example to introduce what ADK is and how we can use it. Just a show of hands, and how many of you have heard of ADK, Agent Development Kit? We got 1, 2, okay, that's 3, 4, 5. That's better than average. So thanks for being there. Wrong button. So this is what we're going to talk about today. I think more importantly, as the previous speaker, Kelly, mentioned, she raised a very good question. How to do career planning in the era of AI? I think that's a very, very good question. Probably everyone has at some point has thought about. I think apart from the agenda, I think what I want to explain why I think Agent Development Kit is relevant to maybe most of you, even though you may not, you may never use actually ADK, you may never use it to build any applications. So I guess you guys all have heard of the phrase vibe coding, right? Yeah. So how many of you have tried to build the application entirely using AI? We got, maybe a dozen of people. How many of you actually managed to build something useful entirely using AI? None. Okay, it's very good news. None of us have actually managed to build any useful application entirely using AI. I hope we are not biased here, because I assume most of us come from computer science background. So yeah, go out to talk with anyone who are not from this background. We haven't used AI to build a useful application from the scratch yet. Now, why is that? Because I think people underestimated the importance of software architecture. Like even with AI vibe coding, it still follows the classic software engineering principle, garbage in, garbage out. So I think most of you can agree, like even with AI-assisted coding, people who understand coding, people who are better at coding in the first place, they manage to make better use of the tool. I think previous speaker Sun also touched upon this, like ideas is very important. And I think this talk is actually most about architecture rather than how to actually do the things. So as mentioned, as my day-to-day job, I'm a game designer and a producer. So I make games. I actually make commercial games. I happen to be a Google developer expert. Don't ask me how I became the Google developer expert. I don't know. And London is where I call home. You can find me on Twitter, although I haven't used and it's not called Twitter anymore. I do use LinkedIn. You can find me on LinkedIn as well. And this slide, whenever I go as a Google developer expert, I always show a slide of my hobby. And I always try to put something relevant to the country I'm visiting. But as you can see here, I really like Spain. And it makes, I think my hobby, what I try to say here is my hobby is making travel journals. But it looks like my hobby is visiting Spain instead. Because I really visited a lot of places in Spain. And it's my third time in Madrid. So back to the topic. What is ADK? ADK stands for Agent Development Kit. And why do we need to use it? So apart from the philosophy we talked about, to explain why we need ADK, we need to go back to the evolution of AI agents. So a few years ago, large language models made I would say large language models became widely accessible, and everyone was mind blown by that. So finally, we can talk to an AI with almost natural language and and expecting almost natural responses. Everyone was very impressed by that, except one problem. At the very beginning, large language model alone wasn't very useful because, yes, you can have a chat with it, but so what? So that's why, I think this was 2023, if I'm correct, and RAG suddenly became a buzzword, very popular in the AI application community. And RAG stands for Retrieval Augmented Generation, which means if you ask AI nowadays, okay, what's the agenda of International Women's Day, Women Take Maker event in Madrid today, it can tell you the most relevant, most up-to-date information because it has retrieved this information from Google search. In ChatGPT's case, it retrieved the information from Bing. So in simple terms, retrieval means the AI model has access to external data sources such as custom databases or some APIs such as Google search. And on top of that, people start to plug in tools around it. For example, nowadays, I guess, with the help of vibe coding, everyone can make some application. Okay, now I know the agenda of Women Take Maker event in Madrid today. Can you add it to my Google Calendar? Things like that. So these are external third-party tools that we can connect to our AI applications and make it useful. So as we know, an agent is someone specialized in doing something. So we call one an LLM model and retrieval and tools this trail an agent because an agent is a specific unit of the application that is specialized in something. And if we put many of these tools, many of these agents together, we can achieve more complicated. We can use it to achieve more complicated purposes. Oh, wrong button again. Okay, so that is a popular multiple agent-based architecture that I think from last year became very popular. So again, if we look at this architecture in a different angle, so on either side of the diagram, so let's start from the one that we are most familiar with, generative AI models. So an agent interacts with a generative AI model, and on the other side, it also connects with tools such as calling external functions, calling external APIs, connecting to external databases. And right in the middle is the agent runtime. So basically, okay, we have the model, we have the tools. What should we do? And Google Agent Development Kit is a framework that's designed to solve the runtime problem. Basically, the classic software engineering challenges, how we can connect those things effectively and correctly together. How can we do the orchestration? How do we solve store necessary user-based information in the short-term or long-term memory? So this is the purpose of ADK. And again, because I don't work for Google, just for clarification, and I'm a Google developer expert, and I'm encouraged to share my personal opinion. And one of my personal opinion I want to share is I'm not a hardcore supporter of AI, despite I'm giving talks about AI, because as we probably heard many times, there are many challenges around generative AI. But I'm excited when I came across ADK the first time because it proposed an architecture that breaks the bigger task down into smaller agents. So it forces us to rethink software architecture force us to rethink, okay, what is the most effective way and the most efficient way actually to solve the problem. Actually, more than often, we may find, okay, to solve this specific challenge, for example, 1 to 1 equals how many? Equals 2. We don't really need a generative AI to do that calculation for us, right? So once we break down our bigger task into smaller chunks, we may well find, okay, some of the problems are better suited for maybe the classic AI, for example, text classification, tagging, this kind of different AI, or some tasks may well not need to use AI at all. I think this is a real opportunity to force us to rethink what is the best way to solve a problem. And not to mention that in the future, we have opportunity to use smaller, more efficient models. For example, like some of you probably have heard of small language models. So I think a lot of people smarter than me are walking towards a direction. Can we use actually smaller data, like a smaller amount of data to solve some specific challenges? So that's what make me personally excited about ADK. And I try to make this session as interactive as possible. I have to say, like, I built this demo kind of, I think, around maybe September or October last year. At that time, ADK only supports Python and Java. And if some of you knows game development, you probably know no one develops games. Very few people develop games with Python or Java. So I would say for this reason, the demo probably is a little bit underwhelming in terms of graphics. It's not like kind of Fortnite or Minecraft graphics you would expect, but it has all the necessary components to be a game. By the way, since the end of last year, ADK started to support TypeScript, which is much more useful in terms of building games. So this game is called 20 Question Game. Have anyone ever played this game? It's a classic kind of a verbal game played usually between two people or one people versus several. So the one person would think about something, object, for example, a cat, a dog, or a pencil, but without telling people who participate. And other participants will try to guess what it is by asking questions that can only be answered with yes or no. So the twist here is because my belief is we should only use generative AI to do things that can only be achieved with generative AI. So the twist of this game is the AI will be the person who asks questions. So as human, we only need to answer yes or no. As you can imagine, this is nearly impossible before generative AI. So let's not make it difficult for AI this time. Because yesterday I went to the bear statue in Madrid. So let's give it like bear. So I will explain actually for the purpose of the game, I don't need to actually type in the word for the AI to guess it. The only reason that I ask the user type in the word is just to validate if this is a suitable word. For example, if we try to type in women tech makers, I haven't tried before, but I think it should reject it. Yeah, it should reject this input because it's very, very difficult for the AI to guess in 20 questions. So if we use the word, let's just say bear, and we can start the game. So this is a live demo. So you use this Gemini. So as all that live demos do, we may have unexpected situations, but okay. So the first question the AI asks is it alive? I mean, it could be a dead bear, but let's assume it's alive, yeah, for the purpose of the game. Is it an animal? I guess so. So the next question is it typically a pet? Probably not. For those with good eyesight, apart from giving those questions, I also ask AI to give an explanation why they ask this question. Is it larger than a person? I think the one in the plaza is definitely larger than a person, so let's say yes. Does it primarily live on land? I would say yes, even polar bears do. Is it a herbivore? I don't think so, right? No. Six questions so far. Does anyone know the answer of this one? Yes, will you say yes? Okay. I don't know enough about bears, sorry. Is it bear? How does it guess it's bear? Yeah, I'm not sure, yeah. It's definitely smarter than me. Yeah, so that's the idea of the game. Yeah, well, yeah. The AI win the game. Actually, it doesn't happen very often when I give this talk, because most of the time, people try to make it really difficult for AI. And good news for you is most of the times, humans still outsmart AI. Yeah, so as I mentioned, if today I were to build this demo again, I probably will use TypeScript because there's much better support in terms of graphics, interactions. Yeah, so with that said, let's take a look at what's under the hood. While graphically it's not amazing, it does have all the elements that make a game. So we have the display layer. So if you use Unity or Unreal, that is the graphic engine that comes with a game engine. And we have a control layer, like in the classic game development, there will be something like to support mouse interaction or keyboard interaction or controller interaction, stuff and the UI stuff like that. That is a controller layer, and everything on the right hand side, I guess it's quite specific to ADK. So we have the ADK runners and sessions, and then we have a simple agent to do the validation that I just explained. So really just simply validate, okay, if the user input is valid, if it's a guessable answer, if it's a guessable word. And then we have the question agent, which uses a multi-agent structure. So there's one agent specialized in asking questions, another agent specialized in guessing the answers. So, if you scan the QR code, you can see the code behind this project. And let's take a deeper look into what is behind this simple LLM agent, the validation agent. So as we previously mentioned, the only purpose of this agent is to validate user input. So if we use ADK on our desktop, once you install the Python toolkit, you actually get access to a very useful command line toolkit that's it does actually a bunch of very different things. So one of them is to create a base agent structure. And don't worry about API key. It's already disabled, so don't try to write it down. So once you use the command adk create, it will actually spin up like the very basic file structure for you, so you can continue working on it. So in terms of agent definition, it's very simple, and hopefully you can see the code from back there. So obviously we reference all the necessary libraries, external libraries, and this part is where we define the agent, and we give the agent a name and specify which model we want to use, and give it like instructions. So because it's an LLM powered agent, so we can actually describe what we want the agent to do, like in natural language. And of course, with Gemini, you can build everything I just showed you without using ADK. But using ADK gives you basically a few tools that's out of the box. One of them is schema validation. So as you can see here, we defined a schema, like output schema for the validation result. So we say, okay, we want a Boolean that tells us if it's valid or not. And then if it's rejected, give me the reason. So we just need to pass the output schema to our agent definition, and the schema validation will be automatically done for us. So this is very useful, like because before we try to build a game that try to use LM as a core gameplay, and it was a couple of years ago, so at the very early stage of LM, and it's a headache to actually force the AI to give a certain format of output, even if we find some tricks to force the AI to give a JSON output. Maybe 1 in 10,000 calls, it still fail to follow the structure we prescribe it to do. So yeah, this schema validation is actually looks very small, but actually very essential. And as mentioned, with the ADK toolkit, it comes with a few things very useful on the command line. One of the, I think, people's favorite thing is the debugging interface. So if we, on the command line, if we type ADK web, it automatically spins up this debugging website. And then you can go to your local browser. You can go to your browser to access this local website, and you can basically select this agent we just created, and to try to interact with it, and it will. It offers a very similar interface as the chat interface that I guess we're all familiar with. So this is a quick way of testing the agent without actually building the rest of the application. And in the events, so this GIF at some point will show, in the events we can also, because sometimes the agent requires multiple steps before it reaches the conclusion. So in the event tab, we can actually trace how the AI reaches this conclusion. It's very useful. And so previously, that was the definition of the agent. To call the agent in the actual application, we still have a couple of hurdles to jump through, which leads us to two very important concepts: ADK runners and sessions. And I think previously we briefly touched upon this. So the agent belongs to this is the official slide from Google. So agent belongs to the execution logic category, and the services are anything to do with the user. So for example, if we want to store some essential user information in the short-term memory, we store them in session services. And then runner is the event processor. Basically, that's the brain of this application. So to do it specifically in code, we have this runners.py. What is important to look at here is we create a session service, a session that to be used by the agent, and then we create a runner, and in here we reference to the agent that we defined previously and this session service. And this is really just the initialization of the runners and the session service. And here is where we actually accept the user input, whether it's elephant or bear or cat, and then actually run the validation. If you think this part of code is strange, because it is, it is because the Gemini gives response like in a stream. So for example, if you ask something, it actually can give like a stream responses instead of one-off, okay, this is final result. You give step 1, 2, 3. So it actually gives a stream event as response. That's why in this code, it uses Python generator, something called the Python generator. So if you're not like really expert of Python, the chances you haven't come across this. So it does look a little bit strange. So what it says is we will run the agent, run the runner that we defined in previous step asynchronously, and then because this event, the response events will be produced asynchronously. So basically, we'll wait for each event to be produced and then catch the response. And in our case, because we only care about the final response, we just need to we say, okay, if this event is a final response, this is what's relevant to us, and then we return the response from the LLM model. So this is the this is almost the entire code for the simple validation agent. And as you can see, while it's not super straightforward, especially if Python is not your day-to-day language, but it's still quite simple, relatively simple to do the whole thing. And then the next thing I want to talk about is the multi-agent pattern. So we mentioned we have 2 agents, one asking questions, another try to make the guess. So we have an orchestrator, which is a custom agent that links these 2 together. And the creation of the guessing agent and the asking question agent is very similar to the step we took to create the simple agent, the validation agent. So it follows the exactly the same way. So we define this agent, give it some instructions in natural language, and we specify output schema that is defined, which is defined here. And the only thing I want to mention is that this is another kind of handy out-of-the-box tool ADK brings to us. Is you can pass it. You can imagine like in this session, there's a temporary data storage, and it's very easy to actually pass data between multiple agents. All I need to do here is to specify output key for the output of this agent, and later we can reference to the responses this agent produced with this key. This is all we need to do, and for the asking agent, we just need to do the same. And the custom agent for orchestration, this is something maybe a little bit more advanced than previous one. So the chances, if you use ADK, you probably don't need to use a custom agent, but I'm just showing, okay, this is what you can do. In ADK, it comes with several out-of-the-box orchestration agents already, and all these out-of-the-box orchestration agents, they are LLM based. which means you don't need to hard code your logic. You just describe your logic in the orchestration agent definition using natural language. But the reason I want to make a custom orchestration agent is that I want to have, I want to have better control over the logic. I don't want like AI to make the decision for me. This is very important in games because while you want the AI to take care of some things, but at the same time you want to set the boundary. It's almost like disciplining a naughty child. Okay, you want them to do things, but at the same time you need to have some boundary. Yeah, so that's why this is also part of my personal belief that I think we should only use generative AI for the tasks that only generative AI can do. If it's something like simple logic, I would prefer actually just do it more deterministic way. So the technicality of making a custom agent is we need to extend a base agent class, and then we override the implementation, and then finally we yield the event. So here it's use yield event because the generator pattern of Python. So this is my custom logic that links the guessing agent as a question agent together. So basically what I'm saying is I'm going to call the guessing agent first, and the guessing agent should produce me a confidence score. If the confidence score is over 9 out of 10, I would think, okay, the guessing agent is confident enough. So let's make a guess. And I guess in our live demo, the agent was confident that bear was the answer. That's why it produced that guess. And if not, if the agent didn't feel confident enough, we go back to the asking agent, ask the agent to ask a question to further narrow down the answer. So this is a custom logic I have. As you can see, of course, I believe if I use the out-of-box LLM agent, orchestration agent, it may be able to do the same thing as well, but this is very efficient and doesn't require a lot of steps of computation. So that leads us to almost end of the talk. So this is a short talk. So we introduced what ADK is. So it's a framework that helps us to rethink software architecture to build sophisticated applications. And we introduced some important concepts such as runners, sessions, and agents. And we demonstrated how to build a simple agent, how to do a multi-agent pattern, how to build a custom agent. But there are actually other very important and useful things and we didn't cover, for example, workflow agents using custom models. And I think in ADK it also have some evaluation toolkit, stuff like that. And I think earlier this year, it also introduced the agent-to-agent support to agent-agent protocol. So if you're interested, there is a Google's official code lab, and it's really, really well made, and I'm sure you can learn a lot more in detail from it. Thank you.
Thank you very much for the talk. Actually, I'm from London, but I call Madrid my home, so it's kind of a reverse of you.
That's a nice decision, yeah.
So thank you very much for the talk. Actually, a long time ago, I used to be a games developer for PlayStation, but obviously I gave it up a long time ago. But this is really fascinating. I'm seeing a lot of elements in ADK that could replace small components of things in games. But what I was curious about was the unpredictability of ADK. In some instances, you mentioned 9 times out of 10 it'll be right, but when it gets it wrong for certain outputs, it can create a problem, right? So do you see more predictability then leading to replacing actual parts of games engines with these micro agents or these small agents?
Yeah, it's a very good question. And the first, a few comments about using generative AI in games. Actually, I just came back from San Francisco. There's a game developer conference there. Both this year and last year, half of the talks about AI, how to use AI in games, or why not to use AI in games. What surprised me quite a lot is in recent 2 years, like 2 years ago, we are saying we will see more like AI native games on the market, but actually 2 years passed. We haven't seen a lot of new things actually in the market and are successful. I think there's still a lot to do, like for game developers actually make better use of AI. By making better use of AI, I don't mean, okay, in Skyrim you can chat with AI assistant. I don't think that is the best use of, that is a good use of a generative AI, but it's not the best demonstration of the capability of generative AI, in my opinion. So I think we are yet to see a lot more like actually good AI native games. And in terms of the unpredictability, I worked on a game project that was funded by a bigger company, and we try to be very ambitious to actually use the generative AI to do the core gameplay. Yeah, unpredictability was a really big issue, and I don't think like ADK itself actually helps to solve the issue. But of course, like if we talk about the evaluation toolkit, ADK provides out of the box. Of course, it helps solve the problem, but it doesn't address the problem directly. It has tools, for example, the schema validation we mentioned, to address those. But I think the way I see ADK is in itself, it's a rather low-tech tool. It just link all this more high-tech tool together and make it more usable, but it doesn't address the challenge directly. And in terms of the hard challenge itself, I think on the positive side, we have seen like real improvements, like even comparing to 2 years ago. But on the other side, I think on the other hand, the fact that we haven't seen like more AI natives games or better AI natives games come out, it's a statement in itself.
Hi, thank you for your talk. I just wanted to know if you've used or if ADKs can be used in everyday life or for productivity, or are they too specific and complex and should just be used for work and product?
I guess depends on how nerdy you want to be. Yeah, so personally, I think I'm very nerdy, but I wouldn't use ADK to help with daily productivity. I think using Gemini app is the farthest I will go. But I have seen like some other people, they would actually ask AI to build a productivity app for them, and then it helps them. I think ADK itself may be a little bit, my personal opinion is maybe a little bit heavy for like everyday use, but who knows?